So with linear equations, which means, y is the power of 1, x is the power of 1, there's no funny business, no square roots, things like that. With linear equations, they make the graph of a line. So often it's useful to put the equation into slope-intercept form, because when it's in this form that I have on the board here, then we can quickly identify the slope and the y-intercept. I've already talked about the slope a little bit in another video. The slope is how fast the line. Oh, it's not getting any better, is it? Right there. There we go. The slope is the distance from. It's the ratio from one point to another point, right? Whatever that ratio is, the bigger the number it is, the bigger the slope. So that's what the m is. That's what that can help us figure out really quickly. And then b is the y-intercept. So it's where it crosses the y-axis. Okay. So that's the basics of slope-intercept form. If you're given an equation like this, and let's say you were trying to compare it to another equation, and it's important to know which one is growing at a faster rate, right? Which one has the bigger slope is what you'd want to be asking yourself. So to figure out what the slope of this line is, we can rearrange it until we have y by itself. Because if we do that, then we have it in slope-intercept form. So I'm going to subtract 4x from both sides to start off. Okay, so we get negative 3y equals negative 4x plus 15. We rearranged it a bit. This got canceled out. Now we have negative 4x plus 15. You could have wrote 15 minus 4x too, or you can cram in the negative 4x right here. Either one is okay. Then to get y by itself, divide every term by negative 3. So y is going to be, look, negative 4 over 3. That's a negative divided by negative, so let's make that a positive. And then 15 divided by negative 3 makes negative 5. Okay, so that's the slope-intercept form of the equation that we were dealing with at the beginning. Now we can tell them what the slope is. The slope is the number attached to x, the 4/3. And it's going to cross the y-axis at negative 5. Okay, if you're given an equation in slope-intercept form, actually let's just do this one over here. Once we have it in slope-intercept form, we can quickly make a graph. It crosses at negative 5, so I'm going to put a dot down here. And we're going to use my slope to count out another point. Remember, the slope is the rise divided by the run. So I'm going to rise 4 points and then run to the right 3 points. Rise another 4 points, run to the right 3 points. There's another dot. And if you keep going in that fashion, you see the points are making a straight line. Okay? Or if you're given a graph and an equation, say it crosses at 1, 2, and it's not a very good graph, but let's say it crosses at 3, 0. What we can do is we can come up with the equation for this graph real quickly. The slope, it looks like we're going down 1 to the right 1 to get to another point. So it's negative 1 over 1, or simplified form, just negative 1. And then the y-intercept is where it crosses the y-axis, and on my poorly made graph, I made it cross at 3. So I could look at the graph and I could figure out what the equation was by using slope-intercept form.